Hi, I'm Chris. This is my brief history of white space and some related white space issues. I think when I originally envisaged it, it seemed a better idea than it did when I tried to write it down. Just getting it down to under 5 minutes and keeping it interesting and coherent is a challenge, but we'll see how we did. Before computers, my great uncle Tub used to run a typography business. This is in the 60s and 70s. He mostly printed business cards and advertising flyers. When I was about 13, he offered to make me some business cards and show me how he did it. Basically, you take a frame and you stuff it full of as many letters as you can because you don't want the letters to move around. It's very visceral, so and selecting letters is quite time consuming, but it did encourage exploring the best placement. It gave you a lot of flexibility because you had different size letters, so you can do small type superscripts and subscripts. He used larger non-printing blocks to allow centralization of letters quickly, so you didn't have to do like 20 regular spaces. And he also had thin spaces, so if you were left and right justifying, you could distribute the spaces evenly between the lines so it didn't look lopsided. At the same time, typewriters were common in both business and domestically. They had three main space controls. They again had regular spaces for word separation. They had a lot of them had a tab mechanism where you had movable metal bars and you released the carriage and it would move forward to where the metal bar was, and this allowed you to line up permanent indentation, things like quotations. It had a return lever for the carriage return, and you get a ping near the end of a line. Correcting errors and doing sub and superscripts was time consuming. Home computers appeared in the late 70s using ASCII. White space here was one of 6 carriage returns and line feeds were similar to what you got on a typewriter and sometimes got a bit confused. Horizontal tabs were under software control. Vertical tabs is the one that usually surprises people because it's very rarely used in programming, but it was quite useful for printing because it allowed the printer mechanism to move down a line without changing the X coordinate, which could save a lot of time. Form feeds were very useful on dot matrix printers. If you wanted to print multiple files out, you could put a form feed between them, and you again had regular spaces. Print languages like PostScript allowed specification of XY coordinates, so you could fine-tune space widths, but the home printers I usually used, if you needed to distribute spaces, it would do two full spaces rather than trying to subdivide the space. And to Donald Knuth, who was writing books on algorithms and didn't like what the word processors at the time were doing. So for instance, the line breaking algorithm for a typical word process, and this is still true for things like Words and OpenOffice, is you would type along until you got to a position where the next word would no longer fit on the line, and it would start a new line automatically for you. Donald didn't like this because it potentially created increased raggedness. So the top example here shows what Word might do for a 6-space column. He instead preferred to do spaces over the entire paragraph. So he wanted to minimize the square of the space left over at the end of the line. So you'll see here what's happened is that instead of having a 0, a 4, and a 1, which has a large discrepancy in the number of spaces of 4, he's reduced the discrepancy to 2 by moving the BB onto the next line. I came across it when I was working on a system to lay out classified adverts in an Australian listings paper called The Trading Post, which is similar to London's Loot, and I'm sure you have others internationally. We had to implement Knuth's algorithm both horizontally and vertically. You've seen the horizontal example, but one of the requirements was to keep each advert in a single column, so you didn't have half the advert at the bottom of one column and half at the top of the next. So this meant that you had to have spaces between lines which would vary. So again, across the entire paper, we did Knuth on a horizontal as well as vertical basis. Knuth's word processor tech went on to have other later spacing innovations like minimizing ink bleed between thin paper by offsetting the text on two sides of thin paper and keeping translations in sync on opposite pages. So for instance, you wanted to have Bible verses in two languages and keep the verses aligned. Okay, so now we jump forward to Unicode. You have all the ASCII white space, but it's added some additional useful things. So if you wanted to keep your numbers in line between two lines, you've got a space which is exactly the size of a figure. You have non-breaking spaces. So if you have something like Chris Jack and you don't want to split the Chris and the Jack over two lines, you could put a non-breaking space between the two of them. You have a wide variety of variable width spaces. Zero width spaces are useful if you want to indicate in a word that this is a good place for a line break, but you don't want to see a space in other situations. You have special language spaces, which I won't go into. You have a next line character, which is different to character and line feed, and a paragraph sticker project. Finished.